This is Josh White with JW Math Tutoring. In today's video, I'm going to go through the 6 hardest problems from the April 2022 ACT exam Form E25. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I begin this video, going through these 6 hardest ACT problems from this test, I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the reason I'm only highlighting 6 problems from this test is because I've gotten hit with copyright strikes from the ACT when I published full reviews of completed official tests. So that's the reason why you only see 6 problems instead of the full 60, which I would love to do, full videos on. Lastly, if you're looking for more ACT practice work, please check out my Improve Your ACT Math Score course. You can find it on Udemy. You can find it also on Teachable. There are direct links to both courses in the description of this video below. And basically, this is a comprehensive overview of the math section on the ACT. It covers your common topics in algebra and geometry and probability and statistics, in addition to strategies like back solving, picking numbers, process of elimination, estimation, drawing a picture, essentially in order to help you solve problems as quickly as possible. And it also includes an entire module on using the TI-84 graphing calculator to solve problems as well. Basically, it features over 10 hours of instructional video along those 5 different modules. So please do check that out. Anyways, here are the solutions to these 6 hardest problems. Okay, now looking next at problem number 36 at the top of the next page. So this is a kind of, this is like a tricky problem just because of the way that it's worded. But basically what's going on here, they have a bunch of choir members. They tried to set them up in rows of 12. They tried rows of 15. They tried rows of 20. And none of them worked, meaning that none of them worked out evenly. And in fact, there were a bunch of even rows with the same number, and then the last row had one less than all the others did. And so it wants to know what's the least number of like choir members that it could have been for this to happen. So the basic approach that I would take with this one is, essentially back solving. So go ahead, start with the answer choices. Start with, say, 44. Okay? So if we're going to have rows of 12, we go 12, 12, 12, and so far we're at 36, and then the last row would have to be one less than that, one less than the 12, which is 11. Now, if you add this up, notice it does not add up to 44. Instead, it adds up to 47. Basically 36 plus 11. So therefore, 44 is not possible. So we can eliminate that. Notice for the next answer choice, 47, well, I've already tested it with the first combination. So now I'm going to do it with the second one. So let's try it now with 15. So 15, 15, 15, and now up to 45, and then the last row would have 14. So if I add those all up, 45 plus 14 is now 59. So notice that 47 is out. 59 so far works for 15. Let's see if it works for 12. If not, then we can cross it out and move on to the other answer choices. So we do 12, 12, 12, 36, plus 12 is 48. And now if you take 48 and add 11 to it, you also get 59. So it works for 15, it works for 12. Now we just have to check 20. If it works for 20, it's the right answer. So we've got 20, 20, we're up to 40. And now, if we do another 20, we'd be at 60, which is more than 59. So we got to go one less than that at 19. And now 20 and 20 is 40, plus 19, we get 59 again. So the lowest number that it works for is going to be letter H, 59. That's the correct answer. And another way you could think about this problem is it's basically asking for, like, what is the smallest multiple of all of the numbers, meaning the 12, the 15, and the 20, and then go one less than that. So in other words, if you asked for like the smallest multiple, um, least common multiple of 12, 15, and 20, that would turn out to be 60, and then you just go one less than that because the last row had one less person, and that's another way to get 59, or another way to think about it. At the top of the next page, problem number 40 is a little tricky one, but it's not too bad in that you just have to kind of like draw it all out and map out all the roots. So I'm just going to use different colors to trace out all the roots, and then we'll see how many total there are. So if we start at the top and we go across all the way and then down, so that is 1. And then if we go across the top still, but then down, then across the middle, and then down, okay, we've got 2. Now if we go still across the top, then down, all the way down, and then across the bottom, we have 3. And now we can go down first, then all the way to the right, and then down, 4. And then we can go down first to the right, then down again, then right again, kind of a step pattern, 5. And then for the last one, we can go down and all the way across to the right, 6. And that should be it. There's basically 6 total patterns. They're kind of like mirrors, of each other. Like the black one on top is just kind of a mirror of the gray one on the bottom. So the correct answer to this problem is just letter G, 6. Next, below it, we have problem number 55. Again, one of the kind of more difficult problems on this test. And so you have an alarm. It's basically beeping. Beeps at 4 seconds, and then at 6 seconds after that. You have another one that it goes at 29 seconds, and then every 30 after that, blah, blah. And it wants to know, you know, for some variable number of minutes, what is the total number of times both of the alarms combined are going to beep, over those minutes. So what I did here is I used picking numbers. I said, let's let t equal 2. So over 2 minutes, how many times do each of these things beep? So rather than list all of the values out, in other words, for the first one, it's going to be 4, and then after 6 more seconds, it'd be 4, and then 10, and then 16, and then 22, and so on. What I said is, okay, the first one's going to be after 4 seconds. So 2 minutes is the same as 120 seconds. So if I take 120 seconds, I subtract 4 from it for the first beep, I'm left with 116 more seconds. Again, this is for, basically alarm 1. I take that, I divide it by 6 because it beeps every 6 seconds. When you do that, and we'll just do it on the calculator over here, it's going to beep 19 more times. So in other words, it beeps once after 4 seconds, and then in the remaining 116 seconds, there are 19 more beeps. So that means for alarm 1, we have the 19 plus the 1 equals 20 total beeps. For alarm 2, I'm going to use the same process. So the first time it beeps is just going to be at 29 seconds. And that means if I subtract that from the 2 minutes, or the 120 seconds, and then divide that by 30, I'm just going to have, let's see, 120 minus 29, 91 seconds remaining, then divided by 30 seconds. This is going to be 3 point something. I mean, if you don't know that or recognize it, you can just do it on the calculator. Excuse me, not divided by 30. Or not divided by 3, divided by 30. There we go. So there's going to be 3 more beeps plus the 1 initial beep to make 4 beeps total. So alarm 1, 20 beeps. Alarm 2, 4 beeps. Alarms 1 and 2 combined, 24 total beeps. So now when I look at all these formulas and I plug in 2 for t, which one of them equals 24? Hopefully you recognize it's going to be answer choice A, which is just 12 times t. So the correct answer to this one is going to be letter A. Again, strategy I used was picking numbers, and then to pick a number of minutes, find out how many total beeps there would be over those number of minutes I chose, and then plug that value into the answer choices to see which one gives me the same value that I calculated. Next problem, number 57, is another fairly complicated one where you have like a small square inside of a larger square, but it's a little tilted, it's a little angled. And they want the area for the smaller square, but notice all the answers are just generic expressions in terms of x and y. There's no actual numbers they give you here. There are multiple ways you could solve this. I'm going to show you one way to do it, and then the second way is actually going to involve, the strategy of picking numbers. So the first thing to notice is, if each side of the square here is x, then if we have some small part here, which is y, then the remaining distance, say from here to here, is just going to be x minus y. So you could go around the square and you could fill in, whatever each of these, x minus y and y. Now, notice, say, one of these triangles right here, you could go ahead and you could do Pythagorean theorem, and that would give you the length of the hypotenuse in terms of x and y, and the hypotenuse is the side of the inner square. So once you get that, you would just basically multiply by itself, and then you'd have your answer. So if we're going to do Pythagorean theorem, we have, x minus y, quantity squared, and then plus y squared, and that's just going to be equal to c squared, or our hypotenuse squared. So now x minus y squared, you technically have to write it out twice and you have to FOIL it. In other words, it's x minus y times x minus y. And it's going to be x squared minus 2xy plus y squared. And then we also have the other y squared from the second side of our triangle. So we now get x squared minus 2xy plus 2y squared. That's equal to the square of the hypotenuse. So technically, if you wanted the hypotenuse itself, we would just square root both sides. In other words, I'd square root this, and then I would square root this, and the squared and the square root technically cancel out. So I could say that the hypotenuse is equal to the square root of this entire long expression. But here's the thing. The square inside, the area is just going to be equal to the value of any of its sides times itself. So now if we wanted to find the area of the square, we would just take, c, which is one side of it here, and we would just square it. And so all that's going to happen is now we're going to get back to the original expression we had, because the squared and the square root are going to cancel out. So we just get x squared minus, again, 2xy plus 2y squared. And that's it. So for this one, the final correct answer is going to be letter E. Now, an alternate way you could do this would be to use picking numbers. And so this would basically involve kind of going through the same process, but instead of doing all these variables, you're going to have numbers to work with. So here's what I mean, and kind of we'll do this out in red. So let's say that, I don't know, the side of this square is 10. In other words, x equals 10. Okay, so x equals 10. And now let's say y is going to equal, I don't know, 3. Okay, so x is 10, y is 3. So now I'm going to go ahead. So this would be 3, and then this side here would be 7. So now if you go through and do Pythagorean theorem, where you've got 3 squared plus 7 squared equals c squared. So we've got 9 plus 49 equals c squared. and we've got 58 equals c squared. So technically each side of this inner square is root 58. However, when we square that, we just end up again back with like, you know, 58 because the squared cancels out the square root. Okay, so the area of this square is 58, and now you go through each of these expressions plugging in x and y and seeing which one of them will equal 58. So the first one, 10 squared, and by the way, I'm just going to, x squared would be 100. It's just easier to do these ahead of time. Y squared will equal 9. Xy will equal 30. So A, x squared minus y squared, 100 minus 9, that is not 58. B, x squared plus y squared, 100 plus 9, not 58. C, xy minus y squared, 30 minus 9. 30 minus 9, not 58. D, x squared, which is 100, minus 2xy, so that would be minus 2 times 30, or minus 60, plus y squared, plus 9. 100 minus 60 is 40. 40 plus 9 is 49, not 58. So by process of elimination, it would be E. But you could, again, go ahead. You could plug it out on the calculator. It's going to be 100 minus 60 plus 18 because it's 2 times y squared. So 40 plus 18 is 58. Correct answer. So that's an alternate way you could get it. Again, basically the approach is the same, but you're using numbers, so it's a little bit easier to work with rather than all these variables. For problem number 59, there are, again, multiple ways that you could solve this. So I'll show method 1 would be to note that they tell you cosine 2 theta equals cos squared minus sine squared, sine of theta squared. So cos of 2a equals, okay, cosine squared. Notice the cosine of this angle A is just equal to b. So taking this formula they give you, I would plug in b here. And now for sine squared, this is where it becomes a little tricky. This is where you have to know the Pythagorean identity, that sine squared of an angle plus cosine squared of an angle is equal to 1. Then you rearrange this and you get that the sine squared of the angle is equal to 1 minus the cosine squared of the angle, because in this case it should actually be a, not theta. And notice here for cosine squared, I'm just going to replace it with what it's equal to, which is cosine of the angle is b, as we're given in the problem, and then b squared. So this sine squared theta right here, I'm just going to replace with 1 minus b squared. And now if you just simplify these expressions, so it's b minus negative b squared. That becomes positive 2b squared, and then we have minus a 1 after it. So the correct answer is going to be letter E, 2b squared. Now, let's say you did not remember or never heard of that Pythagorean identity. Okay, here's an alternate way that you could work out the problem just solely using picking numbers. So I'm going to let A be, I don't know, 30 degrees. Okay, so I go to my calculator and I take the cosine of 30 degrees. Just make sure it's in degree mode first, not radians. Okay, so cosine of 30 degrees, 0.866. Okay, so that means that B is equal to 0.866. So now, what's the cosine of 2 times A equal to? Okay, well, A is 30, so the cosine of 2 times 30 is just the cosine of 60. So that you can just plug in to the calculator. Okay, we get 0.5. So now, when you plug in 0.866 for B, which of these is equal to 0.5? That's basically what we're checking against. Okay, it's obviously not A, it's obviously not B, it's obviously not C. Okay, is it D? B squared minus A squared. So 0.866 squared minus 30 squared. All right, that definitely does not equal 0.5. So by process of elimination, it looks like E, but we can just double check it as well. 2 times 0.866 squared, and then minus 1. So notice because of rounding, it's not exactly 0.5, but it's close enough. It's 0.4999. So that's just an alternate way you could solve this problem by picking a value for A, finding out what the value for B has to be on the calculator, then finding what the cosine of 2A would be, again on the calculator, and then plugging A and B in as needed to the answer choices to see which one matches the value that the calculator gives you. Now we have the last question on the test, problem number 60. It is a fairly difficult question, although once you maybe take a look at it and think about it, it's actually not too bad. So in this diagram, you have a bunch of circles that are tangent to each other. They are all congruent circles because they all have the same radius value. And so what ends up happening is, like, the radius of the circle at the top A is R. So that means this distance here is R, and this distance, from the center out here is R. And the same thing happens with all of the other circles. In other words, put the center here, R. Put the center here, this distance R. Again, this distance R, this distance R. Down here, same thing, R, center point R, R, R. Okay. And the reason we know that, like, basically in the circles in the middle here that these line segments are diameters, or at the end that these parts of line segments are radii, is because it tells us all the circles are tangent to each other. And in geometry, there's a theorem which says if you draw a segment from the center of a circle to a point of tangency, it is, basically perpendicular, or excuse me, draw a radius to the point of tangency, it is perpendicular. So that's what makes, a right angle here, and say a right angle here, which makes a straight line, and that makes, one straight line across here, which makes each of these radii, or in other words, a diameter. So once we know that, basically what you really have in this problem is an equilateral triangle, and ignore the poor drawing here, and each side on your equilateral triangle is 4r units long. Now, if you realize that, there are several different ways that you could solve this problem. The first is you could use the shortcut formula for the area of an equilateral triangle, and that's just equal to square root of 3 s squared over 4, where s represents the value of a side, or of each side of your equilateral triangle. So if you do that, you just would plug in for s the 4r expression. And when you do that and you go ahead and square it out, you're going to just get, root 3 on top times 16r squared all over 4. And then the 4, of course, will cancel out with the 16, leaving a 4 on top. And so your final answer is just going to be 4r squared, and we'll put the square root of 3 after it. So the correct answer for this one is going to be letter F. Now, maybe you don't know that formula. That's fine. Then what you could do is, basically you'd have to recognize, well, since it's an equilateral triangle, this is a 60, we know this is a 60, we know up here this is a 60. Okay, you drop an altitude down, and what that does is it makes two 30, 60, 90 triangles. And I'm just going to reproduce kind of the drawing down here at the bottom. So we know this is 4r, and technically, if you look at the, the large picture over here, if I drop this down, we have, you notice we have like 2r on this side and 2r on that side. So this is 2r. We know that this side is 60. We know up here is 30. So then we just know that the altitude, basically this unknown side, or the altitude of the overall triangle, is going to be 2r square root 3. And that just comes from properties of 30, 60, 90 right triangles. Or you technically could also use Pythagorean theorem to get it that way, but it's just going to be a little messy with the, having the variables instead of actual numbers. But once you find that, then you can use the formula for area of a triangle. So, area equals 1/2 base times height, and our base would be the entire, bottom segment here of 4r. Our height would be this altitude, which we just found to be 2r square root 3. And then when we go ahead and multiply it all together, well, I'll just cancel out the 2's, and r times r is r squared. So I get 4r squared square root 3. Now, notice that's the exact same answer that we got using the previous method, using the shortcut formula. One final way that you could get this that might be a little easier to follow is to use a strategy of picking numbers. So in other words, let r equal 1. Okay? So then what you really have is an equilateral triangle with, sides of 4, 4, and 4. And then if you split that, using the altitude, then what you have is a 30, 60, 90 triangle, with a side of 4, one side of 2, and then this side over here becomes 2 square root 3. Okay? Then go ahead, plug those numbers into the area formula, 1/2 base times height, and it would just be now 1/2 times the base, which is just the number 4, the height, which is 2 square root 3, and notice we get just 4 root 3. So now we're going to take r and plug in the value of it for 1 that we chose, and we'll see which of these answers is equal to 4 square root 3 that we calculated. So starting at the top, okay, r squared is 1, 4 times 1 is 4, 4 root 3. So that one checks. Now we already know that that's the correct answer, but if you didn't, you would keep that one and just move on to the rest. For g, if you plug in 1 for r, it's going to be 6 times 1, which is 6. So that is not 4 root 3. For h, it is 8 times r squared, or 1. So 8 root 3 over 3. That is not 4 root 3. For j, it's 8 times 1, which is 8. That is not 4 root 3. And again, for k, it's going to be just 8 times 1 times root 3, or 8 root 3. So that you could use picking numbers here to make it a little bit easier to solve. If you did recognize it's an equilateral triangle, and that each side is 4r units long, you could use the picking numbers approach to help you actually find the area, because it's a little easier to work with the numbers rather than all these different expressions that have variables or have r's in them. So multiple ways, or I guess multiple approaches you could use to solve this. They all still basically involve finding the area of an equilateral triangle, whether you use the shortcut formula or the standard triangle area formula. If you enjoyed this video, if you have any questions or comments on these problems, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And of course, as I mentioned earlier, check out my Improve Your ACT Math Score course if you're looking for more resources to help raise that ACT math score of yours.